Dear students, in this class we can discuss about two important topics called self-inductance and mutual inductance. So let us start today's class. First we will discuss self-inductance. Okay, so what is the definition for self-inductance? It is noted as L. So the self-inductance of a coil is defined as its property by virtue of which an EMF is induced in it. Self-inductance of a coil is defined as its property by virtue of which an EMF is induced in the coil whenever an alternating current is flowing through it. Okay, so you can keep it in mind whenever we discuss about self-inductance. We can consider a single coil. How to represent self-inductance? I will write a circuit. Okay, I'll consider a coil, okay, to which an AC voltage is applied whenever an alternating current supply is applied. Okay, so this current alternating voltage will drive an alternating current I in the circuit, and this coil will have n number of turns. Okay, so due to Faraday's laws of electromagnetic induction, whenever the flux links the coil conductor changes, an EMF is induced. Okay, this EMF is always try to oppose the supply voltage because of Lenz's law. This is called as self-inductance. Now E is equal to minus N into d pi by dt. Okay, so what is this d pi by dt? D pi by dt is nothing but rate of change of current. Okay, so therefore I'll replace this minus n into d pi by dt can be replaced as E is equal to minus L into di by dt, or we can also write equation for self-inductance as L is equal to n pi by I. This is the expression for self-inductance. L is given by n into flux pi divided by I. Okay, this is the formula we are going to use for calculating the value of self-inductance L whenever they will use a coil. So there is one more important concept called mutual inductance. Mutual inductance is denoted by letter M. The mutual inductance can be explained with the help of two coils. As the name indicates, we'll have mutual inductance. Okay, so let us consider two coils. Keep these two coils side by side. I will take one coil as we used in the self-inductance. Okay, and I will take one more coil. I'll place side besides to the first coil. Now what will happen? Now I'm applying the voltage only to the first coil, and AC voltage is applied. Okay, now what will happen? So due to the voltage applied, now this will drive an alternating current I. Okay, so I will take it as V1 because there are two coils I1. This current will establish a magnetic flux, okay, in the coil 1. Okay, the same magnetic flux is linked to coil 2. Now as for Faraday's laws of electromagnetic induction, okay, the flux which is produced in first coil due to change in current I is also linked to the second coil. Therefore, an EMF is also induced in the second coil due to change in flux. Okay. So therefore, how to define mutual inductance? Mutual inductance defined as the EMF induced in the second coil, that is coil 2. Okay, this is coil 1. So mutual inductance is defined as the EMF induced in the second coil due to change in the magnetic flux of the first coil is called as mutual induction. So either vice versa we can do, either you can apply supply voltage to coil 2, then EMF will be induced in the coil 1 as well as coil 2. The voltage which is produced in the coil 1 is self-induced EMF. The voltage which is produced in the coil 2 is called as mutual induced EMF. Now what is the amount of voltage induced in coil 2 is given by E2, that is E2, it depends on N2, that is number of turns in the secondary coil, and also what is the rate of change of flux in the primary coil, that is di1 by dt, or E2 is equal to N2 into d pi 1 by dt. Okay, so EMF induced in the second coil due to rate of change of flux in the first coil. Okay, that's what the concept is called as mutual induction. The transformer will work in the concept of mutual induction. Okay, transformer works in the principle of mutual induction. Either you can give supply to secondary coil or primary coil. Any one coil we have to energize, the EMF is going to induce in the secondary coil, one more coil. Okay, that concept is called as an mutual inductance divided by M. Okay, so with this I will going to conclude my class. Thank you.